In this video, we are going to solve some problems based on the effect of magnetic field on moving charges and on current carrying conductors. Here we have got a diagram which shows that there is a charge which is moving into the magnetic field. The values are provided to us. It's asking us to find the magnitude of magnetic force. The formula is QVB sine theta. Q is given to us, V is given to us, B is given to us. For angle, if you read the question carefully, it said that perpendicular, it is entering perpendicular to the magnetic field. So theta is 90. We can substitute and get the answer for force, which is 7.9 times 10 to the -12 Newton. Next, it's asking us to find the radius. They have given us the mass. It's a direct substitution into the formula for radius, which is mv over qb. We substitute the numbers, we get the answer as 2.9 times 10 to the -3 meter. Here we have no numbers given. It says that an electron moves in a circular trajectory. Trajectory means path, circular path with radius r in a constant magnetic field. What is the final radius of the trajectory when the magnetic field is doubled? So the formula is r equal mv over qb. We can see that the radius and the magnetic field, they are inversely proportional to each other. So if you double the magnetic field, then the radius must be halved, which is r over 2. Next, we have got a wire carrying current 5 ampere, which is placed and we want to find, there is a point P which is 0.1 meter away from the wire. We want to find the magnitude of magnetic field strength at point P due to the current. So the formula is mu naught I over 2 pi r. All the numbers are given to us. We can substitute and get the answer for magnetic field. The unit for magnetic field strength is Tesla. Now next is what is the direction of magnetic field at point P. So it's easy to find the magnitude just by substituting the numbers. For direction, we have to use the right hand grip rule. So you have to imagine as if you are holding the wire the way it is shown in the picture here, using your right hand with your thumb pointing in the direction of the current. So here the current is downwards, so your thumb will point downwards. Now we can see that point P is on the right side of the wire, and on the right side the fingers are coming out of the page, whereas on the left side the fingers are going into the page. So according to how your fingers are at a given point, that will decide the direction of magnetic field. So at point P, your fingers are going to come out of the page. That means the field lines will point out of the page. The magnetic field is out of the page. Part C, find the magnitude of magnetic field at point P if the current in the wire is tripled. We know that from the formula magnetic field and current, they are directly proportional. So if we triple the current, the magnetic field will also get tripled. Next, we have got two situations with two different wires. So let's focus on the first one. Here it says there is wire 1 which has current flowing out of the page and wire 2 which has current flowing into the page. What is the direction of magnetic field at point P? And P is in between, midway between wire 1 and wire 2. So wire 1, it's out of the page, current is out of the page. Wire 2, current is into the page. So we are going to use the right hand grip rule to find the direction of magnetic field. You know that magnetic field lines would be circular around the wire. So for wire 1, it would look like this. If you point your thumb out in the direction of the current, the fingers will curl in anti-clockwise direction as shown in the diagram. For wire 2, again it will be circular, but this time because the current is into the page, your fingers will curl in clockwise direction as shown in the diagram. But we are interested at point P. So at point P, we can see that both the magnetic field directions are upward. That means they will add up. So magnetic field at P is upward in the plane of the page. For the second diagram is the same thing, but the direction of current, you can see that both the direction of current are into the page. So if we draw the circular field line, we can see that it would appear like this. So magnetic field for wire 1 is downwards, which is B1 down. Wire 2 is upwards. They have equal current flowing through them. That means B1 and B2 would cancel each other out. That means the magnetic field at point P will be equal to 0. Okay, so whenever they give you two different wires, you need to use right hand grip rule to find the direction of magnetic field at a given point and decide whether they will add up or they will cancel out.